You're stick welding with 6013, it's really common to have spots where it hasn't fused to both sides of the plate. I'll show you how to fix it. Hey, welcome to the shop. So I got an email from a viewer about a week or so ago. I've been stick welding as a hobby for about 18 months. I find it hard to get a good consistent weld bead. Can you tell by these pictures what the problem might be? So I've seen this so many times before with 6013. It's notorious for it, but you can't avoid it, and I'm gonna show you exactly how. I'm really excited about some of the footage that I got when I was welding for this video because it demonstrated exactly what the problem is so you can see what's going on. Let's go ahead and get into this. Now, these electrodes have an amperage range of 60 to 90 amps. Let's go ahead and just start off at the bottom of that range and run a weld bead and see what happens. So as I weld here at 60 amps, it seems to be running fairly well, but there's something subtle about this weld puddle that I'm going to show you here in a minute as we compare it. But let's take a look at how the weld turned out. Now, I got a similar result to this viewer where it hadn't fused to both sides of the plate, and I expected this because of the way that it was running. Let me show you what I could see that was different. If you look at the weld puddle, it's important to be able to see the weld puddle and then the slag behind it. But with 6013, there's a whole lot of slag and it tends to mix together really well. Now, let me just show you a quick clip welding with 7018. Here, with this type of electrode, you can see that clearly defined puddle and then the slag following after right on top of it. That's what you want to see with 6013, and you can get a little bit of it. So let's take one more look here and compare the start of this weld with the middle where it was running better. Here at the start of the weld, that slag is just mixing in with the weld puddle, and it's not able to fuse on both sides of the joint, where in the center of the weld, you do have that distinct puddle with slag behind it. You might be thinking, that's great, Tim. How do I actually fix this? How do I get it to run right? Well, the solution is usually a little bit more amperage. The amperage range for this electrode is 60 to 90 amps. I'm gonna crank it clear up to 90. We'll run right at that top end of the range and see if it corrects the problem. I'm gonna make one other change a little bit to my technique. I'm actually going to increase my drag angle of my electrode so I have a little bit more arc force pushing that slag there behind me. I'm running this weld and it's laying in pretty nice. I can see that weld puddle with the slag falling behind, so I'm like, okay, I'm feeling pretty confident that this is gonna be fused to both sides of the plate, but it's running pretty hot. And so I'm having to move along here and it doesn't look like it's fully filling everything in. We'll take a look at that in a minute. Here's the result of that weld. It came out much better than the first. It's fused to both sides of the plate all the way along. Honestly, it's probably good enough for a lot of things. But I do have a little bit of undercut. Now, undercut is where you've melted more material out than you were able to fill back in. And the biggest reason that I think this happened in this case is that it was turned up so high on this thickness of plate, I had to move really quickly. So let's try one more weld somewhere in between. I'm going to turn it down to 75 amps, right in the middle of the range. Here I'm maintaining that steeper electrode angle, and if you watch as I run this weld here, I have to actually push my electrode down in. I'm not able to just drag it along there because it's consuming electrode faster than I'm moving along the plate. So the weld is running really well. I'm seeing that defined weld pool with the slag behind it once again. Now, as I'm welding, it might look like I have a bit longer arc than you've seen on my videos with a 7018. That's because the arc actually burns up inside the flux coating on a 7018, where 6013, the arc is pretty much all exposed. Afterwards, let's take a look at this weld. I've chipped it off and brushed it with a wire wheel, and it came out really well. It's fused to both sides of the plate. There's not undercut. There's one little spot right here that's low. That meant that I traveled a little bit quickly for a second, but overall, it's a good sound weld. Now, along with these changes, it really is important to use just good sound weld technique. The types of things that I teach in my online courses, I've linked those in the description below. If you want me to walk through step by step through the learning process, and be sure to check that out after this video. All right, let's take a minute to just summarize the things we've talked about. One, having those spots where it hasn't fused to both sides of the plate, it's a really common issue with 6013, and it's caused because the slag mixes in with the weld pool and gets in the way. Two, if you want to make sure you're avoiding that while you're welding, you need to look and make sure that you can see the weld puddle and a boundary to the slag behind it. And three, in order to avoid it, you need to increase amperage usually, and increasing the rod angle a little bit will help you out also. So if you keep those things in mind, I think you'll be able to correct the issue with just a little bit of practice. I've linked a few videos in the description that you might find helpful to watch after this one, as well as a link to my online courses where you can walk through the whole learning process step by step with me. Hey, thanks for tuning in, and we'll see you next time.